All right, good morning. Just wait for 1 or 2 minutes before we start the lesson. Or maybe I try to, or maybe I just continue because I forgot the recording finally. Just make it an auto recording. Well, while we're waiting, I would like to remind all of you this Friday we'll have got a quiz, the quiz on chapter 31. So you just memorize the typical reactions of organic chemistry. Okay, I'm sure you can make it. Do you find easy? It's time to study some of them. Okay, for some of the high achievers, you may be required to think of the synthetic pathway. Okay, how would you come up with a synthetic route? How many steps synthesis? Okay, it's now about is out 8:35. So we will show those people on the screen, and that is the list of students who are present today. Okay, so I would like to start the lesson now. So last night we just talked about this one. It is what we call it as a soap and which is quite different from soapy detergent. So we call your memory about what is meant by soap. Soap comes from what? It comes from fats and oil, right? It comes from fats and oil. The use of soap is to improve the cleansing property of water, because water, it is a just wait a moment. Yes, because water it has a very high surface tension, so you have to do something in order to reduce the surface tension of water, such as to wet the material more thoroughly. Okay, so can I call upon some people where some of them they are, could you please turn off the mic, because yeah, I can see some noise. Hear some noise. No, yeah, thank you. So the soap, it is from the fats and oil. So no matter we'll talk about fats and oil, and what are they in similar is the structure. The structure is in form of a triester. And because of we are going to have this, and you are going to deal with the making of soap based on this substances. So in case if I can break this apart and then do the hydrolysis of that, and you can make this one having dual property. What does it mean by dual property? Double property. One is it can dissolve, part of them it dissolve in water, the other part they will dissolve in oil. So the way to make is by alkaline hydrolysis, what we call that saponification of fats and oil. Okay, so if you want to speed up the whole process, you may apply heat. But most of the time, while you talk about the soap on the market, they seldom get heat, especially those DIY soap. What they need to do is to quickly stirring the alkaline NaOH together with fats and oil. Okay, and then you just stir it until the solution become cloudy. Okay, and later on I pour those sticky liquid. Actually, the liquid will become more sticky, and finally it will turn to a solid. So while we are waiting, it's time to pour those mixture in terms of a paste or maybe a sturdy liquid into a mold and wait. How long time will you wait until it is safe? It's about 1 month. Careful calculations of fats and oil with that ratio will make you a soap which can be used for further use. Okay, so how about in lab sense? Well, if we're going to heat it, because the water is quite hot while the solution mixture, we've got aqueous medium is alkaline, the soap is not so is still soluble. in those alkaline medium. So what you're going to do is to sort out those soap and filter off, and you can get what you want. So this is what we stop at it and yet last night, and we covered if the points are the structure of the soap. Just recall your memory about the structure of soap. We have got two parts. One is water soluble, and it is just this part, COO minus, but not Na plus. Remember, Na plus, it is water soluble. It loves water, but it doesn't have any cleansing property. What we focus on is just this part. Okay, what we focus on is just this part you need not know it. This is the only the soap particle we are going to consider. While the other part, it is on this part. It is made up of very long hydrocarbon tail. We call that water hating, or we use the word hydrophobic. So because of this very strange structure, will help clean the material. First of all, wetting reduce the surface tension of water, such that water can immerse into the, for example, cloth more thoroughly. And second is about emulsifying. It would be able to make oil and water mix together. But indeed, it's not a mixing actually. What I want to tell you is that if you take a very closer look on the arrangement of oil in water, it is in form of a suspension, or we call it emulsion, an oil-water mixture. Okay, an emulsion 魚狀物. So inside that we will see the hydrocarbon tail, which is immersed into oil, while the negative charge, the carboxylate head, it is now submerged in the water. And remember, it's not just put it inside, but also you have to, in order to have a good, better cleansing property, what you need to do is to rub it, is to stir it. Okay. Of course, while you are having the plate, you need not shake. Instead, you rub, right? You rub against those plates, oily plates. You rub against those clothes, and you will have such an action, right? You will have a chance of lifting up those oil, and the more vigorous shaking it is, and they will form those oil droplets. So what we will see in macroscopic viewpoint, we will see it is a type of foam, okay, foam. So, or lather, LATHER. So this is what you may see in macroscopic viewpoint, but in the microscopic viewpoint, it is something like this. Okay, so in special well, foam is just the bubbles on top of the water. Okay, so this is what I would like to talk to you last night. And because of the anionic repulsion between those tiny oil droplets, those oil can no longer merge together, okay, because of the repulsion. So this is what you may know it last night. Questions so far? Now this is what you are going to memorize, the detailed step of the cleaning action of detergents in water. So this is the part of that, but of course for the if you want to talk about the surface tension, you are going to tell something more. So shall we take a look on 33.6. So we have got another type of you may find it's not just soap, but also some detergents, right? But what is the difference between soap and detergents? Is it just solid or liquid? It's not like this, but also the raw materials making it is different. Okay, so while we just go over with you what is that, and shall we take a comparison of those? Now, first of all, soaps, they are not so. If you think that soap can clean can clean everything, but it is not so effective, and especially in hard water or maybe in acid medium, also not okay. So why we say that? Because for hard water, they will form water insoluble, it precipitate with soap molecules, while they will hinder the cleansing process. So what is that? So we may have this one is a detergent particle, soap particle. While we will talk about hard water, what does it mean by hard water? The opposite word is soft water, right? Hot water. Can you give examples of hot water? Anyone to know? The water which is full of what? Calcium ions, or as well as magnesium ions. Yes, very good. Mineral water, or we call it spring water, and you may get those hot water. So in Hong Kong, well, our drinking water is soft water. But you go to some other places, just like Europe, most of the countries where you'll get that fountains, those fountain water, it is mainly mineral water. It's because of the landscape there. Okay, something about geography. But don't worry, what we want to mention it is about the hot water. What happened is, if I have a soap, I wash the clothes in hot water, what will happen? These two aqueous, they will merge into solid. It is in form of a precipitate. Well, what will happen? What's the point of having it is precipitate? So because of this part, we have got the hydrophobic part and we've got hydrophilic part, because it is now merged together with our PPT. So this does not act as an emulsifying agent. Okay, so this is what we worry. What's more about acid? Acidic medium. How come in acidic medium is no good? So I would like to put this part acidic medium on the left hand side here. In acidic medium, so what will happen to the soap particles? For example, I mark it this slide. I copy this one as example, C17H35COOH in acidic medium. So I react with acid to form C17H35COOH. So what's the point of handling this one? Now, in case if I put it into acidic medium, those carboxylate will regenerate back to fatty acid. Now, when you compare with this one and this one will have got the cleansing property. But this part, no cleansing property. Okay, or maybe very, very poor cleansing property. Okay, because of you may see that you have got that in no charge here. So for fatty acid, can it be a emulsifying agent? Somebody will think that yes, but still yes, because we have got carboxyl group which will react with water. Now, however, when you compare with this part, carboxylate, this part which has an anionic head, upon vigorous stirring and sticking, you may have this action, while the anionic head is just in the water is outside. But how about this one? Of course, you may do something like this, right? You can still do it like this. But the cleaning action is not so obvious because of this part. This is neutral. It's neutral. Okay, so only by very, very rigorous stirring you can get oil droplets. And remember to flush that part with a very large amount of water, such that you can flush away those oil droplets. Otherwise, what will happen? Finally, those oil droplets will have a chance of merging together. Okay, again. So this is what what is the difference between the two? And worse still, if you talk about the fatty acid, some of them is not soluble. Is that okay? So this is what I would like to talk to you about in acidic medium or in hot water. What's the point of having soap? Now this one, what is that? We may see this precipitate. We've got another name. We call that scum. Scum, S-C-U-M, 浮渣. So this is something not so soluble in water. So that's why scientists in the past will think of the way to tackle both problems. One is it cannot work well in acidic medium. Second is the soap cannot work well in hot water. In case we can produce another cleansing agents which can work well in acidic medium and hot water, it can be used to replace the soap. And here comes the idea of soapless detergent. Okay, so the logic will be this. So first of all, soap has been was invented long time ago, but soapless detergents come later. Okay, come later, because we may find that soaps, the using of soap will have some limitations. Okay, can you get the point? So, and unlike the soaps, the soapless detergent can work well in the soap and hot water. Okay, so what is that? If you take a further look of the structure, it will have again of hydrocarbon tail you may find here, hydrocarbon tail you may find here, or even though you may have this one, what is that? Is an alkyl chain with this, we call it sulfate, SO2, L3 and 4, okay, sulfate as a ionic hand. And this one, what's that? We call that benzene sulfate, because this should be one word only, yes, okay, benzene sulfonate, ion. So these two parts, it is something what we call it as a hydrophilic, okay? But for the remaining part, what you may find that it is very similar. Okay, we have got a very long alkyl chain. So it is something hydrophobic. This is a hydrocarbon tail. Okay, while for this part, it is what we call it as hydrophilic and ionic hand. So this is the common common particles that you may find in soapless detergent. It may be either sulfate or benzene sulfonate. What's next is to take a look on the way to make the soaps, soapless detergents. It is from petroleum. It's from petroleum, a very long synthesis pathway. This is just a simplified version. You need not memorize. Okay, you need not memorize. No, don't worry. You need not memorize. What we just appreciate is the raw materials. It's made by a petroleum. Okay, and then we are going to react with benzene to form a phenyl group inside, and then later on I add sulfonation. It's a type of sulfonation. Sulfonation, which means I add SO3H here. And then later on, I add it with alkaline medium to regenerate. This one is acidic, right? So finally, they would turn it to benzene sulfonate. This is an ionic hand, okay, which is hydrophilic. While this part, it is hydrophobic. And you are going to talk about these substances which act as a cleansing agent. Okay, so indeed, this is what you need to know about the soapless detergent. Now, shall we take a look on the comparison actually? So what we are having so far? It's time to go back to the comparison between the soapy detergent and soapless detergent in terms of the following. So I would like you guys to let me know the comparison for two. Anyone can help? Can you make a comparison? It's time to make a comparison table. Now I'll give you the first one. Raw materials to produce soapless detergent. What is the difference between the two? So shall I take a look on somebody here, right? I see some of you are quite late. Choi Ming, tell me your understanding for those students who are late, those 5 students who are late. You have to tell me the comparison between soap and soapless detergent. First of all, the raw materials of making it. Choi Ming, where are you? vanished, disappeared, 蔡俊明 no. How about 魏翠怡 魏翠怡 can you tell me your understanding 魏翠怡 no. How about the others? Still no. You just left for breakfast. 魏翠怡 I count you 3, 2, 1. Okay. Oh, tell me. No. No. So what does it mean by no? Anyone who can help? Okay. For those who know the difference between the two, could you you may turn switch on the mic and just tell. Triester versus petroleum. So what does mean by triester as a raw material? So naturally occurring raw materials, triester is in form of what? Is it in forms of oil, right? Fats and oil. Okay, fats and oil for soap. How about this part? It is from petroleum. It's a petroleum product. Okay, it's from petroleum. So you need to have a long pathway of synthesis, right? So the symphytic pathway. So how to produce this is by what? Soap. How can we get the soap from fats and oil? 盧少華 盧少華 here. Are you here? How can we produce soap from fats and oil? No. How about the others? Yes, alkaline hydrolysis is very good. I would like to add some alkaline into it and stir it, vigorous stirring it, and you can produce the soap. Okay, mainly alkaline hydrolysis. But of course, if you are going to produce the soap at the laboratory in a very short time, you may apply heat, okay, followed by sorting out process, filtration, rinsing, drying, etc. Something that you normally treat with a preparation of soap. How about soapless detergent? A very long process, right? How we understand this? From petroleum, what will happen? What's the point of from petroleum? This you need to have what? First of all, cracking. Okay, cracking of heavy oil fraction. Later on, you need to do what? You need to add benzene, right? Sorry, fractional distillation. First of all, fractional distillation to obtain long chain with a double bond. Okay, and then you add benzene. You add corn salt. Because the space of them is very limited. Okay, finally, I added with alkaline to regenerate those parts where we have got the benzene sulfonate part. This is one way. Okay, a long process. So because of this, the basic structure of the cleansing agent is different. What's the basic structure for soap? What's mean by that? If I put this as example, this is a benzene sulfonate. So it is something like this, right? A very long chain, and then benzene here, and then sulfonate. This is the structure of cleansing agent. How about this soap? Something like that, right? So what will be the end? COO minus, okay? So similarly, you have got two parts, which is hydrophilic, okay? While you talk about this part, I changed another color, okay? This part, it is hydrophobic, okay? So you may have something similar like this. So what else? What else can be compared? Well, if you both talk about this one, what are they similar? We call it a type of anionic detergent. So, but if you want to take a further look at the functions, the cleansing functions, you may have got some limitation. So especially on different types of water, soap, they cannot work well in what? Works well in salt water, but your turn. Anyone who can, you can tell. Here, Triệu Cao Minh. 我余一斌. Could you please tell? Yes, hot water, that's very good. Hot water, but not work well. Okay? But can work well in hot water. Why? They will form something, what we call. One way. Now it seems is high. All of you go into yes, form scum. It seems all of you go to have a breakfast, right? You just left. Many of you didn't tell anything. Cho Jiming, you want to say something? Yeah? Your chance. Cho Jiming, what else? Work well in salt water, can work well in hot water. What else? How about acidic medium? They can't work well. Okay, how about soapless detergent? Okay, so this is what we just talked about the summary of the comparison of those two type of raw materials for making the detergents. One of them is soap, the other one is soapless detergent. Questions? Any questions? Yeah, good. So remember this comparison table for further use. Okay, you better put it inside your book as well. While you have a consolidation of idea, right? Sometimes you need to have to make a comparison for those. And similarly, 2 days ago, while you talk about condensation polymer, right? You may make a comparison between condensation polymer and addition polymer. So I will give you a chance. So go home and try to make a comparison of those condensation polymer and additional polymer. What is it? How will we compare? Just like this table. Okay. So what we just mentioned about those detergents, we have got anionic detergent. And indeed, outside the market, we may have some cationic detergent or something what we call this anionic detergents as well. So you take a look on this. Don't worry about the difference particle size. But what we want to let you know here is to let me know your understanding. This part, cationic detergent. How come this one would act as a cleansing agent? Okay, no Siwa, tell me. Now you talk about cleansing agent, we have got two parts, right? One is the ionic head. The other one is what? The other one is it is hydrophobic part, and the other one is hydrophilic part. Could you please circle it onto this structure? Which one is hydrophobic? Which one is hydrophilic? Which part? No. Yes, the circle part. What is that? Yes, hydrophobic for the circle part. How about hydrophilic? Hydrophilic. Where? This one is just hydrophobic. Hydrophilic here, is it? Whole circle. Why not you make a circle for all? Now, what is the special point of cationic detergent is having a place which is a cation. Tell me where. Where is the cation, or which one is a positive, right? This one, yes, that's right. This one. This part, it is hydrophilic. So remember, this is the anion. Okay, the salt is very strange. Now, indeed, the cation is a very bulky cation. The whole thing is a cation, right? While for this part is hydrophilic. Can you get my point? So talk about these three parts, the hydrophobicity is very, very minimal. Why you compare with this? Why? C18H37, it is a very long hydrocarbon chain. Or we'll call it hydrocarbon tail, right? So if you talk about hydrophobicity, this is the major place where you get hydrophobicity. Of course, this one is also hydrophobic, but it's too small. It's too small. The effect of it is very, very little. Do you understand? Okay, how about this part? Non-ionic detergents. Similarly, now could you please help circle it for me? Which one it is hydrophobic, hydrophilic? Where? Yeah, good. It's easily found, right? It is hydrophobic. Good. Which part is hydrophilic? Yeah, mainly, right? And especially, yes, that's right. Both I will give you correct. Mainly on this, right? This part, right? Which means the whole part here, it is hydrophilic. But if you want to talk about non-ionic detergents, okay, the cleansing action, you need to do something more to it. For example, you need to rub it more vigorously, such as together with running water, so as to rinse away. those dirt or oily dirt onto a, for example, in the dish, right? We commonly use it as a dishwashing liquid. So, any questions so far? So you may have got so many different types of detergent, right? Anionic one, cationic one, or even non-ionic one. We have got different types of detergents, and mainly whether or not I say it's detergent, we need two important parts. What are those two? Now this one cationic is detergents, right? What are those two? We need two parts, right? One is hydrophobic, the other one is hydrophilic. Do you understand? Questions? Anything you still have doubts? Let me know now. Now, how many of you think that well, I understand to a certain extent what is said about soapless detergent, the cleansing action. Could you please put up a hand? Tell me. Raise your hand. Let me know. One. God. Two. Orange to 飲茶. Three. Just three. 盧少華, what do you think? Or just three? How about the others? No. No. Okay, all right. So, nice. Okay, so shall we take a look on the consolidation, right? Of these parts. Now, so where we just have a coverage of this, right? The soap. I come from fats and oil. I do alkaline hydrolysis to produce very strange structure. Part of them it is water loving, part of them it is water hating. And only by having this we can do a cleansing action more effectively. Now it's quite different from non-ionic detergent. Okay, this one is more effective. And they will have a wetting property and emulsifying property. Now, if you want to tackle the problem of washing the materials in hot water or in acidic medium, you need to change the soap into soapless detergent because it will have some limitations. And soapless detergent is mainly done by, is made by crude oil fractions. I do cracking, I get something double bond, a very long chain double bond part, and then do the for some of the synthetic pathway, to get this. Okay, so both we have, but what is in common is that we still have hydrophobic part, which dissolve in oil, and the hydrophilic part, which is dissolved in water. Okay, so the way to make this is making a emulsion. Okay, questions? Easy. So shall we take a look on question 8 on your MCs 280. In an experiment, a mixture of castor oil and excess concentrated NaOH solution is heated for some time, and then a small amount of corn NaCl is added to the reaction mixture. Solid product is produced. Which of the following statements concerning this experiment are correct? Take a look at question 8. What do you think? B. Okay, yes, this one is correct. This was correct. It's alkaline hydrolysis. Yes, that's right. This is wrong. The solid form is not glycerol. So what is that? This one is correct. It's to salt out. Yes, that's right. How about this? If I change it to correct one, how to correct this? The solid form is what? It is in form of a soap particle like this. Okay. So the answer is 1 and 3 is B. And then you take a look On question 9. Question 9. Which of the following could be produced by the alkaline hydrolysis of triglyceride? Question 9. What do you think? No idea, huh? All fails a lip, right? D? Yeah, D. Now, so this part, what is that? What is it? Is glycerol. Well, this one, it is sodium carboxylate. It is a alkaline hydrolysis product of oil, but we cannot find this. Okay, question 9. Any questions? How about 11? The structures of 3 compounds, they are shown below. Which of them can form a stable emulsion when shaken with oil and water vigorously? Stable emulsion. C? Chen Junhei just said C. Is it correct? C? Yes. Why? Again, if you want to make it stable emulsion, which means we have got a emulsifying property, right? So yes, we have got this 2 parts, which is the right-hand side, which is that hydrophilic, while for the remaining parts here, it is hydrophobic. Question? Nope. Now, if not, we've got about 8 more minutes to go. You take a look on the long question. Warm up. Warm exercise 14. This is the systematic name of the alcohol that is formed by this hydrolysis. Alcohol. So what is that? So could you please have a try on that? What is the systematic name of that alcohol? No response. Are you here? Propane 1, 2, 3 trial. Yeah, good. Propane 1, 2, 3 trial. Propane hyphen 1, 2, 3 hyphen trial. Okay, we've got a hyphen here. You miss out hyphen here. So number and letter hyphen. And draw the structure of other organic products of this hydrolysis. So how you deal with this? A very complicated structure, right? But you may have some easier way out. Yes, that's right. And then you add something. Now finally, I know it is glycerol. Propane 1, 2 trial, right? So how about the remaining parts? I add something. It is O minus Na. Now, so sodium hydroxide, so it's Na plus. So I write, you just copy this down, and this is the answer. Can you get the point? You just copy this, and you may get the one structure. Okay, the second structure. So what is that? O minus here, and then Na plus. Another structure. The first structure, O minus Na plus, the first structure. Can you get a point? So as long as you know the way to cut, but you may know the way to go. Okay, question? Now, the last question before the end of the lecture, right? This one is too easy, right? I try to make it more complicated, which is on this part. Question 18. The structure of triglycerides found in olive oil is shown below, like this. Olive oil can be used to make soap by heating with concentrated NaOH. So don't worry too much about the different types of oil, right? So as long as it is form of triglycerides, you just continue your work, and you can still get the answer. So A1. So what's that? Olive oil can be used to make soap by heating with concentrated NaOH. Name the type of reaction involved. Name the type of reaction. So you have to make a correct spelling of the word. Can you spell the word correctly? You may type it here, right? You may type it on the chat. Okay, saponification, yeah. Good. What else? Can I have another name? Yes, alkaline hydrolysis. Good. Write the chemical equation involved for the formation of soap from olive oil. Wow, crazy. So what I'm going to do is to add what? Alkaline, right? How many NaOH do we need to add? In case it's 1 mole, you need to add 3 moles of NaOH, right? Why is it 3 moles for sure? Because you need to break down this 2 and 3. 3 esters, right? Triester. So you have 3 NaOH, 3 hydroxide ions, each of them tackling the hydrolysis of each ester linkage. Okay, so what will be the product? The first one, it is glycerol. The other part here, so what I'm going to do is to copy them a very, very long way, and copy until hit this part. So I just want to show here. So what is that finally? Now for the remaining part, you have to draw it by yourself, okay? Until I've got C double bond O, C double bond O, C double bond O. So how will you finish this part? It's involved of Na plus, right? Na plus, and then O minus, Na plus, O minus, O minus, sorry. Yeah, this part, never write it as a covalent bond. Never, okay? It's not covalent bond. Instead, it is the ionic bond, right? But you may find that this and this, they are the same, right? You may merge the two. You may merge the two to form this, 2, and then make it 1. Do you understand? Something like this. And then very long. Okay, do you understand? Okay, how about B? Explain the cleansing action of soap formed from olive oil. Huh? Can you memorize it? Can you explain the cleansing action of soap? Yes, you need to memorize. First of all, soap process is cleansing property as it is a wetting and emulsifying agent. Okay, you may get 101, right? So you know what will happen next is to tell me something about wetting, something about emulsifying. Okay, first of all, wetting. Soap reduces the surface tension of water such that water can wet the surface more thoroughly. So this is what we just explained it as a wetting agent. Okay, how about emulsifying agent? Oh, very long uh, way of presenting the work. First of all, yes, good. Hydrophobic part, hydrophilic part, you need to tell. The hydrophobic tail, you know, it is in form of hydrocarbon dissolved in oil, while the anionic head, it is hydrophilic, dissolved in water. Point 1. Point 2. What will happen to surrounding water molecules around the oil droplet? Okay, they will trap the anionic head and lift the grease off the surface. Point number 3, you need to do something, right? Upon stirring, small oil droplets are formed. Number 4. Yes, so that is the part. The old small droplets will come together again. Due to the repulsion between anionic heads. Okay, so what happened to number 5? Finally, you need to do what? Washing, very good washing or rinsing. So what is that? You form it an emulsion, right? Here, emulsion. Done, finished. Can you manage to memorize these? So what are they? If you're asked to relate that paragraph to some cartoon-like stepwise diagram to illustrate what happened while you form an emulsion, could you please locate the page for me? Now, somebody you will still got puzzled. How come it's so long? Right? Tell me the pages. Where do we find these paragraphs? In which page? You've got some diagram, right, for illustration. Which page? Where? Page 198. Yes, they're very good. You go to 197, 98, right? You may go it backward to this page. So this is the pictorial representation of showing the cleansing property of soaps, right? This is the part. So I do hope each time you may spend some time on memorize this. Which means this chapter 33 has come to an end. Congratulations. So tonight we would have a revision of this chapter by doing some consolidation exercise. Right? And do you still remember this morning I asked you guys to have a comparison of addition polymer and condensation polymer? Okay, I will give you the whole morning, right, to come up with a comparison table. Okay, or if you can manage, you may draw it first, and while you meet tonight, I will show over. Okay, if you can manage, I can open the Zoom and then you attach the folder in the chat room. Right, do you see that? Just like this one, you press the button here and give me your picture, and I will click it and then I'll show it to the others. Right, just all of you can learn. So my question is, can you make a comparison? Okay, can you make a comparison between addition polymer and condensation polymer? So this is the question. Okay, so I would like to have your understanding tonight. Questions? Now, if not, I will just stop it here. Before you leave, I would like to check the attendance finally. So because today is a lesson, I would like to count the attendance. So this is attendance. 趙家明、若斌、鐘正南、温志偉、盧少華、文希。And then 黎允正、陳俊熙、蔡俊明、朱俊輝、李俊傑、余子豪 ，and 徐家榮、梁善維、李卓俊、李健朗、李彤、魏卓賢、胡嘉龍 ，and then 袁天佑 ，who absent? Who absent? Tell me who are absent. Who? Any neighbors in which you cannot find? Oh, 吳正豪 number 22. Yes, this is 吳正豪. 吳正豪 absent. Who else? Is it 22 or 23 students in this class? So anyway, Chen Weihao. Oh yeah, you have got a 2. Thank you. So I would like to let them read those paragraphs and then let me know the understanding tonight. Okay, I would like to see that 2 guy tonight. Okay, see you. Bye. Goodbye, class. Bye bye.